Hello, Calculus. Today, taking a look at some limits to infinity and beyond. 3 different ways: graphically, numerically, algebraically. First off, we're looking at page 250, determining infinite limits. Find each limit. This is example number 4. If you graph this function, you will see that it clearly has an asymptote at x equals 1, which is not a surprise given the x minus 1 in the denominator. The numerator at 1 would be 1 minus 3 is negative 2. Divided by 0, anything divided by 0 is going to be an asymptote. Anything that's not 0 over 0. So graphically, we're taking a look at this. And you can see from the left, as you get close to 1, we're going toward infinity. As x approaches 1 from the left, the limit of f of x is infinity. And you can also see that as you come at it from the right, it goes down to negative infinity. The limit as x approaches 1 from the right is negative infinity. Because the limit from the left is positive, the limit from the right is negative. Overall, the limit as x approaches 1 of f of x does not exist because it is different from the left and the right. This is not a surprise. You know all this stuff. How about numerically? What happens as x is getting close to 1? Take a look at this. So we'll define our function. And let's find out what's f1 of 0.9, f1 of 0.99, f1 of 0.999, 18.9, 198.99, 1999. We'll party like that. 18.9 from the left. Keep it color-coded. 18.9 from the left. 198.99 and 1999 from the right. We are looking at 1.1, f1 of 1.01, and f1 of 1.001. Negative 20.9, negative 200.99, and negative 2001. Negative 20.9, negative 200.99, and negative 2001. You can see that from the left, the numbers are getting bigger. We are approaching infinity. The limit as x approaches 1 from the left of the function is infinity. The limit as x approaches 1 from the right is getting huge and negative. It's going toward negative infinity. The limit as x approaches 1 from the right of f of x is negative infinity. One of my worst infinities ever. But what that means is that because those are different, the limit as x approaches 1 of f of x does not exist. Last one, analytically. This can be a biggest challenge, but we'll think about this. This is involving thinking. When x is slightly less than 1, what do you have going on? Numerator, 3 times x is bigger than x squared if x is close to 1. Because if x is close to 1, x squared is close to 1 times 1. 3 times x is close to 1 times 3. So there we go. So that means x squared minus 3x is negative. On the other hand, scroll down please, thank you. On the other hand, x minus 1 is also negative. So we have negative over negative. We have a positive value. This will be positive. Makes sense? and x minus 1 is close to 0, so we have a positive value. The limit as x approaches 1 from the left of f of x is going to go toward positive infinity. On the right, when x is slightly more than 1, we have the same, that 3x is bigger than x squared. So x squared minus 3x is going to be negative. On the other hand, if x is bigger than 1, then x minus 1 is bigger than 0. That's going to be positive, so we'll have negative over positive. We will be going toward a negative number overall. Negative over positive will be negative. The limit as x approaches 1 from the right-hand side of f of x is negative infinity, which means overall the limit as x approaches 1 of f of x does not exist. So 3 different methods. Graphically taking a look at what it does from left and right, numerically, seeing what the numbers do from the left and the right, and analytically by thinking about what happens as you go from the left and the right, thinking about what happens with positive and negative values. There you go. That's enough for today. Thank you very much.